Alright, good morning. This lesson is for my Honors Integrated 1 class. I'm just going to discuss a couple ideas today, but before I get started, I want to just hope everyone's doing alright. I got an email, and the question was about concerns with regards to grades. Let me say this. Third quarter grades, don't worry what they were. Alright? All that we can do right now is do what I'm assigning. So let's just try to do everything that's assigned to us in the fourth quarter. So this quarantine literally is our fourth quarter. So we've been in quarantine for just the fourth quarter of our semester. So please do all the assignments that I assign. I understand that some of you want to bring your grades up. Don't worry about what your percent is in the class. Just worry about getting all the assignments turned in. Do realize that I've been, I hope that I've earned the reputation of being a very fair teacher. I'm still trying to figure out how to handle this situation with regards to your grades, but again, just please do all the assignments. So today, I want to just kind of ramble a little bit. I want to discuss kind of the concept behind indirect proof. That was something I mentioned the other day. And then the other thing I want to talk about is that angle, side angle, triangle problems, they can be hidden. And I like to elaborate on how they can be hidden. But let me first talk about the indirect proof idea. So I wrote on the board a theorem of what we call a conditional statement. And the conditional statement means that if you have something, then you get something, right? And so if I have a point that's equidistant from the endpoints of a segment, I get the fact that that point is on the perpendicular bisector of the segment. So this proof was actually done in the book as an indirect proof. And an indirect proof, again, means that, it's a way to argue about something without actually arguing that something. And so what I want to do is I want to just talk about the structure of that type of argument. And so just below this conditional statement, I wrote a very vague general statement. And so I have if something, then we get something, right? And what I want to point out is that indirect proofs, you need to understand what the possible results can be. Sometimes there's 2 possible results, sometimes there's 3 possible results, sometimes there's a lot of possible results. And so this indirect proof is really nice because there's only 2 possible results that we saw in the book. The point is either on the perpendicular bisect or it is not on the perpendicular bisect. And so the idea behind an indirect proof will be the following. Let's say that, we know that this is going to happen. But what we're going to do is we're going to ignore that this is going to happen and accept that this is going to happen. And so as we make the argument about what we know can't happen, somewhere along the lines, we're going to catch this in a lie. And when we catch it in a lie, that means that this is not possible at all. And so we realize that this can't happen. And so the indirect concept means that since we argued that something false has to happen when we assume this, since this can't possibly be true, it forces the only other possibility to be true. So you indirectly argue that something is true by arguing that this only other possibility can't be true. And that's what they mean by indirect proof. Again, it's a very neat style to make a proof. Very deductive meaning like a detective kind of work, right? But again, this is the structure behind an indirect proof, and they're hard arguments to make. I believe in the book, the contradiction, the lie that comes out is you actually realize that the length can't be zero. I forget what exactly it was. Somehow it forces it to have this happen. So, so that's, I just wanted to mention, kind of the idea behind the indirect proof. Again, you argue what you know can't be true, and you find that in a lie, and since that can't be true, it forces the only other possibility to be true. Alright, so that's an indirect proof. I want to check that one off. So the second thing I want to talk about, with regards to yesterday's lesson, we can call this, lesson 20.2 part B. Alright. And the big idea from 20.2 is the concept of the triangle congruence through this type of pattern, where if I have two triangles and I have an angle, a side, and an angle, and in the second triangle I have the angle, the side, and the angle. So if I get this congruence pattern, I can then say that these two triangles themselves must be congruent. So that was yesterday's lesson. So today I want to just discuss how angle side angle could be hidden. Okay. So let's suppose I have two triangles. And I'm going to hopefully pick nice numbers to work with here. So we'll say you're 100 degrees, you're 30 degrees. And I'll just say that this side length is 15. And then I have my second triangle that's 15 for that length. And this is 50 degrees. And this is 100 degrees. Okay. So we do not have the angle side angle pattern. In fact, we have something that's not close to it at all. Now, what I want to point out or remind you guys is that I know the three angles of any triangle add up to 180 degrees. And so in this triangle, I have 130 of that 180, which forces this angle here to be 50 degrees. And in this triangle, I have two angles that add up to 150. I need 30 more to get up to my 180 degrees. And so now I actually do have this pattern where I have a congruent angle. I'll use a different color. I have my congruent angles. I have my congruent side, and I have my second pair of congruent angles. So this was one way that the idea is hidden. Okay. Now there's also another variation of angle side angle, and it looks like this. So let me say this. If these two angles are the same as these two angles, and three angles in a triangle add up to 180, it forces this third set of angles to be congruent. So I could take this idea and I could just say the following. I know that this angle was the same, this side was the same, this angle is the same, this angle is the same. So let's just say if these two angles together added up to 140 degrees, as well as these, that means that these two angles themselves would each have to be 40. So it's very easy to conclude that the third angle in a triangle, or in triangles that have two of the same angles, the third angle must be the same. Alright, so here's what I want to do. Let's take away some things from this picture. We knew that these two angles were the same to begin with, right? These two angles being the same as these two angles force this angle to be the same. Now, let's just say that we have two triangles that look like this, where I have two pairs of congruent angles, And then I have a side that's congruent in both triangles. Now notice this side is next to the angle with the 2 arc marks as well as this side. Okay? This is what we call angle, side. Angle, side. Alright, angle, side literally is a variation of angle, side, angle. And so, again, I just wanted to show you guys that angle, side, angle could be hidden in some triangle problems. So, if you have this pattern where you have 2 pairs of congruent angles and the congruent sides are next to the same angle, you can say that I have congruent triangles because of angle, side, angle, or you could just say, well, these 2 angles are the same as these 2 angles, then that will force this angle to be the same as that angle, and you could say, well, the triangles are congruent by angle, side, angle. So there's a couple ways to make this argument happen. I'm not assigning any work with this lesson. I just wanted to talk about a couple things with regards to the idea of an indirect proof. Again, it's a hard argument to make. It's a high-level argument, but I think if we see the structure of that argument, it might make a little bit more sense. And then I wanted to hit on how angle, side, angle could look. So again, I hope you guys are doing well. Please make sure you're doing all the assignments I give you. If you're having any issues, please reach out. Email me, ask on the Remind app. Let's just make sure we're getting through this this quarantine in the best possible way that we can. Have a good day. I will post the next video tomorrow.